I'm going to do numbers 1 through 5 on this video with my P8 class, and then hopefully we have time before the bell rings to do number 7. I did number 6 already with my P3 class. All right, so this is getting into quantitative variables. So all those questions we just did about the two-way tables and then into the segmented bar chart, that was about categorical variables from chapter 3. This is, guys, we're talking about August here, August, September, a long time ago. This is now getting into chapter 4 and into chapter 5 about quantitative variables. So we have units. So this one is showing you a stem and leaf plot, which that's not going to be super important. I'd be shocked if you got more than one stem and leaf plot on the AP exam. Most likely it'll be histograms, right? Hopefully you feel confident with those, right? Or box plots or dot plots. Those are kind of the three main things, with histograms being the most important. All right, so here we have a stem and leaf plot showing the ages for CEOs from a group of corporations. Which of the following is not a correct statement about this distribution? There's actually two of them that are not right, because this review book isn't perfect either, right? They make mistakes, right? So when it says distribution is bell-shaped, I've never used the phrase bell-shaped. What is the phrase that I would use for that? Unimodal. Very good, Mia, right? I would use unimodal for bell-shaped. Does this look unimodal? Yeah, it's kind of like one main hump right here. So I'd say that's fine, right? I'm not that concerned about that. Have I ever said that a distribution is showing skewness to the left and to the right at the same time? No. So that is one answer, right? A distribution cannot be skewed both directions. It's either to the left or to the right, or it's not skewed. Now, the center. Do you guys remember the types of statistics that we've used for the description of a center of a distribution? Mean is one. Very good. What's another center we've used? What I recommend as a statistician? Median. Very good, Ezekiel. You can also use mode. Did we ever use the mode really in this class? No. We mostly focused on median and then mean. Okay? Now, in a moment, we're going to talk about spread. Do you guys remember measures of spread? That's one. Standard deviation is one. That's the average deviation from your data values to the mean. Range is one. What up, Ezekiel? Very good. IQR, do you remember what that stands for? Interquartile range. Those are all good. Now, here's the key thing I want you to hear about this one, Benjamin, okay? So whenever I decide to use the median for center, what range should I use with median? No, I should use the interquartile range. If I choose mean for my center, what should I choose for my measure of spread? Standard deviation. I try to teach you guys back in the first semester, early on in this course, that if you choose median, it links with IQR. If you choose mean, it links with standard deviation. And the key thing there is the shape of the distribution. If the shape of your distribution is unimodal and roughly symmetric, you're free to use whatever you want. All right? Most people will use mean and standard deviation. What if your shape shows some skewness or potential outliers? What should you use for the center? Oh, man, we need to read that Barron's book. The median. We should use the median, because if there's skewness, what is going to happen to the mean with that skewness? It'll be pulled. The median, I'm not saying the median won't get pulled, but the median is more resistant. It doesn't get pulled as much as the mean in that direction, okay? So if it's showing skewness or having any potential outliers, you should be thinking median and IQR. Okay, for all that being said, is the center around 60? Sure, this looks good. I'm fine with that, okay? The spread here, I think they're trying to tell you the range. The range is the highest minus the lowest. Is the lowest 28? No, what is the lowest? 22. I should have probably made this clear how this is read. This is 22 and 28. So two CEOs are 22 or 28 years old. We have a CEO that's 33 years old, 36 years old, 42 years old, 47. You get the idea? All right. So actually, this is also incorrect. They're trying to say that one is correct. But technically, the spread is from 22 to 90. All right. And then in terms of outliers, visually, does it look like there are any values far away from the data? No. But if you really wanted to figure out if there was an outlier, you'd have to mathematically do it. So really, this makes me upset, right? Because what word should be here? There are no potential or possible outliers. Because if you say that, that means you've done the math already, which have we done the math? No. So I'm okay with this, but you know my caveat there. Throw that word possible or potential in there because we haven't done the math. Okay? I am. Number 2. Sorry? Well, so they told me the answer. I'm just the answer key. They're saying it's B because you can't have skewness in both directions. But technically, D is also wrong. It should be from 22 to 90. They made a mistake when they made the key. Excuse me? All right, then. Number 2. Which of the following statements are true? Stem plots are useful for both quantitative and categorical. I hope you know that this is false, right? Because stem and leaf plots should only be for quantitative, right? Should only be for quantitative, not categorical. So this is not true. Remember, categorical data, you're going to see two-way tables, segmented bar charts, things of that nature. Pie charts, which we never really use. Stem plots are equally useful for small and very large data sets. Go back to this one. All right, how many CEOs were here? 2, 4, 6, 8, 8 plus 8, 16, 17, 18. There were 18 CEOs in this data set. What if instead of 18, there were 1,800? Would that be easy to do with all those numbers coming out of this way? No, right? So when it says that they're useful for small and very large, they're actually only useful for small data sets. Very large data sets, what would I recommend? I would recommend, thank you, Mia. I can't even finish the question before Mia says it. Thank you, Mia. Right, I'd recommend a histogram, really all the time, but a histogram with large data sets for sure. So also false. Stem plots can show symmetry, gaps, clusters, and potential outliers. Can this show you the symmetry, gaps, clusters, potential outliers? Yes, it can. So this one is actually going to be just Roman numeral 3. Again, I know these first two questions were about stem and leaf plots. I don't want you to think that that's going to be important on the AP exam. It's very not important. Okay? Let's do 3. Which of the following are true statements? All symmetric histograms have single peaks. Can you guys think of a symmetric histogram that would not have just one hump? Could you think of a symmetrical histogram that has 2 humps? Can you draw it? Like, could I draw it? Does that have 2 humps? Yeah? Is it, I mean, I know it's just a sketch, but is that essentially symmetrical? Yeah, so is that going to be true? No, it's not true, right? Most of the time it's true, but there are cases where it would be false. All symmetrical bell-shaped curves are normal. Now, again, I don't really say bell-shaped, right? I say unimodal. Let's think of a unimodal one. Is this unimodal and symmetric? Yeah? Is it perfectly symmetric? I mean, I try my best, right? But again, just because it's unimodal and roughly symmetric, can I assume normality? No, you have to actually be told that something is a normal model. All right, so 2 is trying to get you to go backwards. All right, now what if I tell you it's normal? If I tell you that something is normal, then you can take it to the bank that it's what? Unimodal and symmetric. And you can actually take the word roughly out. The moment you know it's a normal model, right, you could take out the word roughly symmetric. So 3 is what they're going for here. C. That's it for 3. Let's do 4. Which of the following are most likely to be skewed to the right than skewed to the left? So can I draw one that's skewed to the right? All right, thank you. You guys see my skew to the right? Okay. Let's think about household incomes. You guys know what that is? Household incomes? Yes. Okay. Do you think it would look like that? Or here's one, I'll draw one skewed to the left. Which one would it more look like? The one I just drew? You think it'd be this one? That a lot of people are making a good amount of money with a lot of a less amount making not much money? Unfortunately for our society, it is this way, where we have most people making not a ton of money and then a very few amount of people making a lot of money. So it would be skewed to the right. So this one's going to be okay. What about home prices? I know you probably don't necessarily know much about this. Which one? But where are most home prices? Around a certain area? With a few are expensive? Because if you choose this one, you're saying most of them are really expensive with a few that are not. I would argue it's this one as well. Okay, now this one can be tricky. I don't know how many of you have your license, all right? But age is a teenage driver. So what do you think is more likely, a 15, 16-year-old driver or an 18, 19-year-old driver? Probably more likely it's 18, 19, right? Because a lot of people wait till they're 18 to get their license as well. I'm not saying you did. I'm saying some people do. So I think that last one is finally a chance to be potentially skewed to the left. We have more people in the 18 and 19 age range as opposed to 15, 16. So I'm going to go with not 3, but 1 and 2. This can be tough, especially when you're trying to think about it. All right, let's do one more multiple choice, and then we'll do that free response and be done. All right, here's a histogram of test scores. Which of the following statements are true? The median is 75. What do you guys think? Is the median 75? So the 75 would be here, all right? But again, I don't know. It doesn't give me a scale. So if you wanted to make a scale, what do you think? Like this is 1, 2, 3, 4, 5. You guys okay with that? You guys good with that? So this would be 1, 2, 1, 2. So if you wanted to calculate how many in terms of the median, right, you would find the middle number. But what happens when you count? This is 1, 2, 3, 4, 5. So this would be 1, 2, 3, 4, 5. So our median is going to be somewhere probably in the 60 to 70 range, right? Because that higher bin at the beginning means that the median is going to be closer to it. All right, so 75, even though that's halfway between 50 and 100, is not the median. If the passing score was 60, most students have failed. Well, let's see. We can just take a little count here. So here's 60. How many students have passed in my scenario? 8. All right, how many have failed? All right, is that most have failed? No, that's most have passed. Let's see. So we have more students scored between 50 and 60 than between 90 and 100. Yes, right. I'm saying that this is 5 students and this is 2 students. So 5 is more than 2. You're right. It is C. We're almost done. I want you to go to the very last one, number 7. Skip 6. I've actually already done 6 with my P3 class. So you can watch that video if you want. So I'm going to go to, okay. Mm-mm. It's about soccer, so maybe it's too soon for that. So let's go to 7. What? Wasn't the shade? It's like you just had the end of your season. Maybe it's too soon? All right. Number 7. The winning percentage for a Major League Baseball team over the past 22 years are shown in the following step plot. Do you guys see how to read it? All right, so 55 and then the bar, then 6 means 55.6%. For their winning percentage. You guys know what it means for a winning percentage? Yes, you take the number of games played, how many you won, divide them, that's your percentage. So if you have a 60% winning percentage, you're winning 60% of the games you play. That's really good in any sport. Yeah, 6 out of 10, right? So again, if you're over 500, that's like the phrase, that's over a 50% winning percentage. That's good, okay? All right, so here we go. Let's do the lowest value. So what's our lowest value? It's this 46 and the 0, right? So 46.0%. So that means there was a season, I don't know, so there was a season in which this team won 46% of their games. Is that good? No. That's probably not going to result in going to the playoffs. Now, letter B is probably the most important one that I want to talk about with this question. It says describe the distribution. And again, I would encourage you to watch number 6 because number 6 has a dot plot. This is another stem plot, but really histograms, dot plots, stem plots, box plots, these are all for quantitative variables. So when you read this on the AP exam, you should be thinking about describing 3 things. Shape is one of them. Shape, center, and spread. Alonzo was right. Shape, center, and spread. So really, your brain needs to know these three, how to describe these three things. All right? Now, we've talked a little bit about different measures of center, measures of spread. Guys, keep this simple. If this is on the AP exam, you don't have to go into what is the median, what is all that. Do the easy ones, right? Just say the middle is, all right, or the range is the lowest to the highest, right? Keep it simple. Don't try to make it more complicated. How would you describe the shape of this? Kind of hard to see here. How would you describe the shape of this? Ooh, nice. I agree, Ricardo. He said bimodal, I believe. Bimodal has like kind of one hump here, and then they have a gap. See the gap here? And then we have a kind of another hump. So I would say it's bimodal with a gap in the data. Nice. Well done, Ricardo. Okay. How would you describe the center or the middle of the data? We could actually find the median if you wanted to. Do you guys want to find the median? Okay. What do you think the center is? Yeah, it's kind of tough when there's a gap. We'll do it like this. You guys remember how to find the median? So you cross out the lowest one, the highest one. Just keep going like that. You don't have to cross it out. I'm doing it for you. Okay, so it's going to be between these two, 49.3% and 49.4%. So what's the average of that? 49.35%, right? So the median is 40, or did I say 49? Yes, 49.35%. Okay, now again, keep it simple here, guys, for the range. We already know the lowest win percentage. What was the lowest winning percentage? 46%. What's the highest one? They actually tell you in the little thing. 55.6. So the range is between 46% and 55.6%. Okay. You could have gotten away with saying that the center is around 50%, but it's just because of that gap, it was a little tougher to do. Okay, last question, letter C. Give a reason that one might argue that the team is more likely to lose a given game than win it. Any thoughts on how to answer that? What could be a reason that you think this team is more likely to lose a given game than win it? Excuse me. Thank you. Say it again. I agree. So we have 1, 2, 6, 10. That's 13, right? So 13 seasons where they lost more games than they've won. So if there's 13 out of 22, how many seasons have they won more games than they've lost? 9. Now, again, there's not a lot of information here about when these seasons happened, right? Because if you're telling me the last 4 seasons are these highest 4 numbers, then I'm probably thinking they're more likely to be winning, right? If you think of the Astros, some of you Astros fans in here? No? Okay, I'll just say it. All right, the Astros back in 2012, I guess even earlier, 2010, 11, and 12 were really bad, right? Losing over 100 games. Then slowly it started to get a little bit better. And recently, they've been one of the best teams in baseball consistently for the last 5-6 years. Okay, so again, would they have some really bad numbers up here? Absolutely they would, but they'd also have some really good ones as well. So again, I would love to have more context, right, of when these are actually occurring. So I'm going to put what Ricardo said, which I agree. There have been more losing seasons than winning seasons. But again, context is king here. If these winning seasons are happening, recently in the last few years, then I'd probably be more inclined to say that they would win more games.